Did you have any problems defining your intervals? When to use a hard bracket, when to use a soft bracket? Yeah. When to use a hard bracket, when to use a soft bracket. Was everybody okay with the first two? Three? Good. That's important. Get used to using your interval notation. I think it's far easier when you take it off of a number line. Okay, number 4 and number 5. Number 4 was just a plain old inequality statement. And again, just to try to get you to work your interval. So, was this okay? It was probably too simple, and you weren't expecting it to be this simple. But it was just a simple solve me. I like X on the side. If you switch it, remember to switch your sign. Okay? I think it reads easier reading X is greater than or equal to negative 17. It shows you where your arrow goes this way. You follow the arrow this way. This way is reverse thinking. And it works fine as long as you reverse it. God bless you. This one was your and statement. Just like we did your absolute value and statement. We dropped it down and we solved both sides at the same time. So cover this and solve it as if you're solving 1. Add 6, all 3 parts. Divide by 3, all 3 parts. It builds your and statement. And again, just to get this into interval notation. Okay, just kind of like making sure you understand your number lines and interval notation part. Questions? No? Okay. Now the good stuff. Yeah. Sometimes I forget. Alright, set this equal to 0. Remember, to find your critical values, set it equal to 0. Don't use your inequality. Everything goes to the left-hand side. Factor and test. This is a nice quadratic, so it goes like this. Is everybody kind of getting the feel with the quadratic in there? That is your x-axis, and those are where your roots are. So you can see where your y's are positive, where your y's are negative. They could also do this with a quadratic that goes the opposite way. That goes down. And then it just is, on the top there, it's positive. On the bottom there, it's negative. Okay, so everybody's okay with this? Ask me questions, otherwise I'll assume you're getting this, right? Factor, set them equal to 0. If not, put this in your y equals, and look at your table. Test each part to the left, to the middle, to the right. Okay, test where it's positive and negative. In this case, you wanted your negatives, and these were open circles. So you wanted this piece right in here. This was another nice factoring. You wanted your positives, your or statement. Your greater gives you an or. Your less than gives you an and. Making sense? Greater, less than. It'll kind of start to make a little bit more sense. Factors of 45, that gave you the difference of 4, 9, and 5, and you wanted it greater than or equal to. Now, number 10, this is just reverse. This is easy to factor. This guy, watch. This 1 can only go 1 and 1. 2 only has one set of factors, 1x, 2x. What matters is where you put the signs, the plus and the minus. So these are your middle terms. They make a smile. Work out your middle terms. You know your first term is going to be okay because you took the factors. You know your last term is going to be okay because you took the factors. Work out your middle term. You want the higher one to be negative. That's this product right here. So for that product to be negative, there's your negative, there's your positive. You don't like factoring.
I know that.
Yeah, but it's the same as if I switched it around. It's the same as that. It's just that now this is your 1 here versus your 1 in front. What's nice is 1 only has one set of factors. Technically, it'll take you maximum 2 times to get this right. If you did this, 2x minus 1, x plus 1. Because this can only factor to 1 and 2. And you checked it, and you say, oops, that's wrong. All I have to do is switch my signs 2 times and it's right. Maximum. Don't be afraid to try it. These are things I want you to get comfortable seeing because, number one, you haven't been comfortable factoring. So as soon as you see A is not 1, you say, oh, can't do it. You can. In order to conquer math, you got to think. You got to just keep thinking about it. Think, try different things. Don't be afraid to try. And here's another one you might want to do A times C with. Okay. Let's set this equal to 0. When all else fails, A times C. We can't divide by 2 because your middle term only is 1. So A times C, this works every time. This is going to give you 6 times a negative 2, gives you negative 12. What are factors of negative 12 that add up to 1? 3 and 4, which one has to be negative? Good. Plop an X right next to it. That gives you this. So take this out. It doesn't matter what order you put this in. And then group. Group the first. Actually, Algebra 2 started to do a lot more grouping. We always had 3 types of factoring. Greatest common factor, perfect squares, and trinomials. Algebra 2 has really been leaning towards the 4, the grouping. What factor can you take out of this first group? And what are you left with? Okay, now I need, whatever I take out of this piece, I need it to look like 3x plus 2. Negative 1. And there's my factors. 3x plus 2. If it helps, cross it out like this. What's left? 2x minus 1. There's your factors. This works every time. And even this one didn't have too many that you could play with because 2 only factors into 1 and 2. And 6 factors into 2 and 3, and 1 and 6. And you could just try them. It would maximum take you probably 4 times to try them and get them right. If you were stuck. I know number 12 is always confusing when it's greatest common factor because everybody's looking for a trinomial or a perfect squares. These are not perfect squares because 3 and 12 are not perfect squares. So factor out, always look for your greatest common factor first. Factor out your greatest common factor. You have 2 choices. You can factor your perfect squares or you can set that equal to 0. You want the zeros of your equations. Now you have 3 zeros. Now you're really going to have to either test, you have to put it in your y equals and either match up your diagram to this or test it and see which one works. And again, even though you're looking for the positive, you also want the 0. Watch that track with the 0. If that 0 is there and it's filled in, you need that 0. Questions? Oh, this is looking good. Okay. Everybody's good with this? First step we're going to do is to find any domain restrictions. And in a denominator, it cannot be 0. So if we have a fraction, we have to set any denominators equal to 0. And we're going to find your domain restrictions. Then we're going to set your whole inequality equal to 0, keeping everything again on the left-hand side. You may end up having to find a common denominator and make the left-hand side into one term. This one's a tougher one. Then you're just going to find the zeros of the numerator, you're going to find the zeros of a denominator. And you're going to test the intervals. And I'm going to show you a little way to make sure that you're on the right track. We can do this with your calculator. And then we're going to write your solution. So we're going to start with the second problem first. The part where everything is already on one side. This is a rational inequality. Already we have a problem with the denominator. So our denominator cannot be equal to 0. So we set this and we factor this. So what are factors of 15 that add up to 8? Good. So x cannot be -5, and x cannot be -3. So our domain says, take these out, take -infinity to -5, or -5 to -3, or -3 to infinity. This is our domain. This is called our restricted domain. Restricted because we weren't allowed to use all the possible numbers. We had to restrict it to all of these because we could not use -3 and -5. Now your inequality is already on the left-hand side, and we already have one term. One term means there's one fraction, not two separate ones, or not a plus and a minus, or in between them, or not another term or a constant, whatever. Everything is one. So we find your zeros of your numerator, and then we find your zeros of the denominator. The denominator is easy because we know those zeros. God bless you. Since we didn't change anything, don't we already know the zeros of your denominator? God bless you. The zeros, God bless, are these guys. These are your zeros. This is what made your denominator become 0. God bless. Okay, so now let's do your zeros of your numerator. The numerator is this. So we factor this one. So now we have your zeros of your numerator, your zeros of the denominator. And we put this on a number line. So we find your number line, and we put this a -1, +1, a -5, and -3 in the order the way the number line works. So -5, -3, -1, 1. Here's the tricky part. The denominator can never be 0. So regardless of what this sign is, it can never be equal to 0. The denominator is always going to be open. So these roots will have to be open because we can't use -5 or -3. So the denominator is always open roots. The numerator depends on whatever that inequality sign is. If it has an equal, then we close these. Okay? Now, we really have no clue what this looks like because it's not continuous. It has breaks in it because there's certain numbers that we can't use. So we're going to have to put this in your calculator. We're going to put this in your calculator. We're going to go to your y equals. Whether you use a fraction key or whether you use a slash for a divide, if you use the slash, make sure you use parentheses. If you use the fraction key, you're fine. Whoops. Okay, and my denominator. Okay, now here's a nice little, let's look at this first. All right. See the -5 doesn't let you use it, and the +3 is not going to let you use it. It's got some weird looking things going on because you had some breaks in here. So when we look at your table, your -3 and your -5 say error. See it? They say error. Because we can't use those. That's why we definitely know that those circles are open. So now we're going to have to test. Let me just rewrite my number line over here. you're going to have to test all these test intervals. So you're going to look to the left of -5. So we look at -6. All you're looking for is positives and negatives right now. Positive. Between -3 and -5, -4, what's that guy? Negative. Between -3 and -1, positive. Between -1 and 1. So what's the 0? Negatives. Okay, and to the right of 1, 2 is positive. Okay, does everybody see how we did that? You really are dependent upon your calculator for these. Really, they're difficult to graph. You'll be graphing these in about another month or so. You'll be graphing these and you'll know how to graph them. But right now we're kind of stuck depending on our calculator. So now we go back to your problem and you wanted anything greater than or equal to 0. So you want this side, you want this one, and you want this one. So your -infinity to -5, this one's open, or your -3 to -1, this one's closed, or your 1 to infinity.
So there's no solving.
There's no solving for this. It's an inequality, so remember, just any inequality has a number of answers.
So
And
figure nothing anything, just figure out what the roots are.
this is your answer. Because any inequality that I give you like this, there's no one solution. You're going to end up with an inequality. Right? You're always going to end up with more than one answer, so you end up with an inequality. So that's the answer that we're looking at. Now, I told you there was kind of a way to cheat a little bit. If I'm not sure where my factors are, this one's not so bad because I didn't have to manipulate it and get it to one side. But if I'm not sure that I have the right factors, I can go back to my y equals. And I can go to my y2. And I can put this in my factored form. So if you go alpha y equals, this will give you, I don't know if my board's going to take it. Oh, it did. Okay. This will give you a fraction bar. Put it in exactly the way you factored it. X minus 1 times x plus 1. This one's not bad because we really didn't change much. But sometimes you'll make some big changes. X plus 5 times x plus 3. Okay. Oops. Alright. These two should give me the exact same graph. Did I change anything? Nope, but just factored it. So when I graph this, I should see one graph only. If you saw another graph come out, and actually my dark sign is on, you can put the y2, darken it. Just darken this once. Yeah, oops, went too far. There it goes. So you'll see your original graph, and then your second graph will right over it. There it goes. See it? See it right over it? That's when you know you got this right, that your factors were the same. This one wasn't so bad because we didn't change anything, but the next one we had to change a little. Okay. Questions? I know you're not fond of fractions, but this I think kind of makes you a little bit easier about it. All right. Now we go to this one. So before we begin, let's look at a domain restriction. What, if any, is there any x value that I'm not going to be able to use in this domain? 5. And you got that because you said x minus 5 equals 0. So you said when x is 5, that's not going to work. Regardless what this inequality is, that's not going to happen. So my restricted domain, all the other things that I'm allowed to use, is negative infinity to 5, or 5 to infinity. Oh, sign in the label for me, please. Okay, so restricted domain out of the way. Now, notice the next step on this says set the inequality to 0. Everything has to be on the left-hand side. So we have to take this one over here, and we have to move it to the left-hand side. We have to move it to your left-hand side. So subtract 3. Good. Now we have a little problem. Now we have to find a common denominator. This is your third step. Find a common denominator and make this into one term. You're looking for your zeros of your numerator, your zeros of the denominator. You need one term. So I have to make this into a common denominator. And because this is an inequality, we need to keep it one term. We can't cancel any denominators out. We need to keep the common denominator. No cross multiplying. Just find me, look at your denominators, and find me the factors that they both will satisfy. X minus 5, what you said? Okay. I need an x minus 5. This guy needs a 1. I don't really need to put the 1, right? So now, easiest way, leave your denominator here. This guy has an x minus 5. So I just copy down the top. Watch your minus sign. This guy does not have an x minus 5. So it's the same as if I multiplied top and bottom by x minus 5. Just for that one term, right? Because I need to make it the same. So I've got 3 times x minus 5. Everybody okay with that one? What we did was find a common denominator. If I had this, and I needed to make this into a common denominator, I'd put this over 1. And what would your common denominator be? Not just look at your bottoms. 5. This has a 5, so I keep the 1. This needs a 5, so I multiply the 2 times the 5, right? Same thing. It just looks a little worse when we put variables in here. Now, resolve this. We've got 2x minus 7, and we're going to distribute a negative 3. Minus 3x, good, plus 15. Keep this over your x minus 5. And collect your left terms. What's a positive 2x and a negative 3x? What's a negative 7 and a positive 15? Okay. This is your reduced inequality. This is it. Okay. This and this should be exactly the same. We didn't change anything. We just found a common denominator and we cleaned it up a little bit. So now we do zeros of your numerator. So take your numerator. There's only 1 out here. And there's only 1 for your denominator. Which we already knew that one because we did that restriction, right? So we solve this. We subtract 8. You got to solve for the positive x, so divide by a negative 1. And x is equal to 8. So let's section this off. Only 2 intervals, only 2 x values we have. So it gives us 3 test intervals. Now remember, the denominator can never be 0. So the 1 with the 5 is an open circle. The numerator looks at the inequality sign. If it's equal, then we fill it in. Okay? Now, I have no clue where this goes either. Well, kind of, but we're going to put it in your calculator and find out. And we're going to put it in twice to make sure what we factored was right. They look messy, but they're really not that bad. So your first one is your original one on the one side. You're going to say 2x minus 7 divided by x minus 5 minus 3. Everything has to be to one side. Right? That's when we moved it over. This is the one we took here. As soon as we moved it over to this side, we take that one. Okay? Now, in my second one, I want to make sure that all my factors work out, right? So I'm going to take the last thing I ended up with, the last one. And we ended up with negative x plus 8 divided by x minus 5. Oops. When I graph this, I should see the same exact graph. This tells me if I did everything right. So here's my first graph. Look, I can't use 5. It cut it off. Here's my second graph, and it's the same exact graph. See it? So that means that what I did was correct. I factored everything. I found my common denominator. I took my factors. I found my zeros. Everything was good. So, test. Here's your number line. What do we have on your number line? 5 and 8. Go to the left of 5. The left of 5. Any of these will do. I'm just going to bring it down so we can fit 8 in there also. So you're here. Both of these are exactly the same, and that's what we wanted. So to the left of 5, we'll take 4. Is the y positive or negative? Negative. Go in between 5 and 8. Take 6. Is the y positive or negative? Positive. Go to the right of 8. Negative. So, here's your inequality. We know this is all good. And we wanted less than or equal to 0. We want your negatives. We want this one or this one. So negative infinity to 5, open, or close bracket, 8 to infinity. You're going through a lot of steps, I realize it. But you're doing nothing that you haven't done before. You're finding your domain restriction. You're setting your inequality to 0. Everything goes on the left-hand side. You need to have one term, so you need to find that common denominator. Do not cross multiply. You can never cross multiply on one side, and you can never cross multiply on an inequality. Find your common denominator, convert your numerators. It takes a little longer. Gather all your like terms together and put it in your calculator. You're definitely going to have to put this in your calculator. Alright, you only have the 6 problems for homework. I think they'll take you a little while.